Okay, next let's have a look at some questions to do the discriminant and quadratics. This should be useful for most IB courses, additional maths, A-level, comes up on pretty much everything. So here we go. But basically using this idea, well, the solutions for the quadratic formula, which you should know, is minus b plus or minus the square root of b squared minus 4ac all over 2a. The bit that we actually need for this is the b squared minus 4ac bit. Basically, if this is positive, then we have this first thing here, which is two solutions. If b squared minus 4ac is equal to 0, we have one solution. And if b squared minus 4ac is negative, well, we can't square root a negative number, so not without imaginary numbers, and therefore we get no solutions. So we get either two solutions, one solution, or no solution. Okay, so this is what we're going to be using in the following questions. Okay, first one, here we go. This is kind of a relatively straightforward starter. So we've got x squared minus 3x plus k squared equals 4, two distinct real roots. Find the possible values of k. Now, you've got to be careful with this one. They've put it equal to 4, but our formula only works for a quadratic, equal to 0. So let's take away the 4. So then we get this equation here. If I'm doing this question, I would always write down what is a, what is b, what is c. A is the term in front of the x squared, so a is 1. B is the term in front of the x, so that's minus 3. And c is the constant term. Well, k is just a number, so therefore k squared minus 4, that's just a number. So therefore c is k squared minus 4. Now I've got that, stick it into a formula. Two distinct real roots, therefore b squared minus 4ac must be greater than 0. Stick it in with the brackets, put the brackets in first, you're going to guarantee yourself some method marks. Minus 3 brackets all squared minus 4, brackets 1, brackets k squared minus 4 must be greater than 0. Okay, now we actually try and expand out the brackets, and hopefully I should get this. So 9 minus 4k squared plus 16 greater than 0. Now I've got this. There's a few ways of doing it from here. I prefer this method. So I've rearranged it, so I'm going to get 25 is greater than 4k squared. So I've rearranged it to look like that. The reason I've done this is because then I'm going to do a little sketch to actually work out where my solutions are. Divide both sides by 4. I've got 25 over 4, and that is greater than k squared. So I've done a little sketch of k squared. If I square root 25 over 4, I'm going to get either 5 over 2 or minus 5 over 2. And this is basically saying that I want 25 over 4. Basically, I want k squared to be less than 25 over 4. So I draw my little sketch here. This is the line 25 over 4. When is k squared less than this line? It's going to be for the red part here. So therefore, that tells me the solution is going to be when k is between 5 over 2 and minus 5 over 2. So this kind of like sketching a quadratic. Remember, this is not the real quadratic. This is just simply to help us solve the quadratic inequality at the end. Okay, so there we go. So when k is between minus 5 over 2 and 5 over 2, then this original equation will have two distinct real roots. Okay, second question. Find the values of k such that the equation has two equal real roots. When I say two equal real roots, that just means like one distinct root. So we're basically going to have b squared minus 4ac equal to 0. Same as before, let's put a is 1, b is minus 4k, and c is minus 3k. Stick that into our formula, so it's going to be a bit easier because it's equal to 0. Minus 4k all squared minus 4 times 1 times minus 3k equal to 0. 16k squared plus 12k is equal to 0. There's no constant term here, so we're just going to be able to factorize out with a single bracket. I'm going to get 4k bracket 4k plus 3, and then I could solve that. Either k is 0, or if I make this bracket 0, I'm going to get k is minus 3 over 4. Okay, next one. No real roots. Well, no real roots. I know that b squared minus 4ac must be less than 0. Let's have a look. A is 1 this time, b is 5m, c is 25. stick it into my formula. Again, just put your brackets in, make sure you don't make any mistakes. You'll get the method marks, 5m all squared minus 4 times 1 times 25. Just be careful, 5m squared all squared is 25m squared. I've rearranged this and bring it over here, so I get 25m squared less than 100. I'm going to use the same method that I did before. Divide both sides by 25. I get m squared is less than 4. There's my graph of m squared. If I square root 4, I'm going to get either 2 or negative 2. So that gives me the two possible solutions here. And then when is my graph of m squared less than the line for 4? Well, it's between those two. Therefore, m is between negative 2 and 2. Okay, two more, I think. Here's the next one. We've got x squared plus px plus 8, two different real roots, and then therefore b squared minus 4ac greater than 0. Here we go, a is 1, b is p, c is 8, p squared minus 4 bracket 1 bracket 8 greater than 0. Same as the last one really, p squared minus 32 greater than 0. Again, draw my graph. I want p squared and 32, those are my lines. Square root 32, I'm going to get root 32 or negative root 32. And I want p squared greater than 32. So there's my line for 32. When is it greater? It's either this part or this part of the line. Therefore, when p is greater than root 32, or when p is less than negative root 32. Okay, and I think this is the last question. Yep. Find the values of q for which the quadratic equation qx squared minus 4qx plus 5 minus q equals 0 has no real roots. This is a bit more of a tricky one. Let's start off with exactly the same method. A is q, b is minus 4q, and c is 5 minus q. No real roots, therefore we want it to be less than 0. b squared minus 4ac less than 0. Stick in the values, so I'm going to get b squared minus 4q all squared gives me 16q squared. Take away 4 times q times 5 minus q, must be less than 0. Simplify that out. I'm going to get 16q squared minus 20q plus 4q squared. Let's simplify that one. And I get to this stage, 20q squared minus 20q must be less than 0. And I then factorize this out. This will become clear in a minute why I've done that. So I've just said, right, I can take out 20q. So I've got 20q and a bracket q minus 1 less than 0. Now I get to this stage here, and basically I've ended up with another quadratic equation. Now, if you're thinking about it in terms of graphing, it becomes easier to understand what's happening. Now I'm going to draw this graph here, the graph of 20q bracket q minus 1. Which is going to basically look like this. Now, in effect, I've got the q on this axis rather than x. So when is this graph equal to 0? Well, when q is 0, it's that point there, and when q is 1, which is this point here. So basically this graph, if you want to think about it like 20x bracket x minus 1, if you want to think how would you plot that graph, it would look like this. So I've got this graph here. When is this graph less than 0? Because that's what I'm trying to do. Well, this graph is less than 0 between 0 and 1. So therefore, remember, because this is q, therefore the answer is when q is between 0 and 1. So what does that mean? That means when I put q is between 0 and 1 into the original equation, I'm going to have no real roots. Just remember that this graph that you've just sketched here, that's not the same as the original graph. This is simply just to help you solve a new quadratic inequality. So there we go, some of the easier style questions to do with discriminants and quadratic inequalities.